So mark your own. We'll bring out our favorite student again. A lot of students are having trouble with some of this. A lot of students in a related news story haven't been keeping up with the homework. So it says, circle the 3 graphs that represent polynomial functions. Guys, I want you with me. If you look at lesson, I think it was called 6.1, we said that we've been looking at 3 main, well actually that's a fib, 4 polynomial functions. We've been looking at what we called the constant function, something like that. That was when you had an equation like y equals 4. Or it could be below the x-axis, y equals -4. That's a polynomial function, which certainly matches C. We've been looking at linear functions. We said that any straight line is a polynomial function. I glanced at the remaining ones. I don't see a straight line. I guess all lines by definition are straight. I don't see a line. We said that we can also look at the quadratic function. That's the one that you spent lots of time last year doing. That was the parabola. I went looking around and I said, hey, there's a parabola. And then we said we've also been looking at the cubic function. The cubic function looks like this, or like this, which looks like that one. Now, what can't a polynomial function have? It can't have gaps in it. There's a fancy word for that. We say polynomial functions are continuous. Actually, we said they all have domains of all reals. Oh, it can't have gaps in it, and that's the absolute value of a sinusoidal function, in case you're interested. It says, for each polynomial function in question 1, determine the degree, the domain, the range, and the constant term. I'm going to go in order, so I'm going to do graph A right there, graph C right there, and graph D right there, because I noticed that for some reason I went 1, 2, and 3, even though the graphs up there were different. Anyways, as long as you keep track of where you put the information. So first of all, the degree of that constant function, degree 0. The degree of a quadratic, degree 2, degree 3. What is degree? It's the exponent on the x, the biggest exponent on the x. That thing, that degree, also tells you a whole bunch of information, among other things, what it looks like, but also how many possible roots there are, things like that. Domain. All reals, all reals, all reals. All of these, the first one goes from negative infinity to positive infinity. The second one, which way is the parabola open, up or down? Down, does go from negative infinity to positive infinity. And the third one goes from negative infinity to positive infinity. Domain's kind of boring for polynomial functions. The range is a little more interesting. So looking at, oh, sorry, I said I was doing graph A, the parabola first. Good gosh, Mr. Dueck. The parabola, then the constant function. Sorry, guys. C has a degree of 0, the constant function. I was going in order of degree instead of in order of graph. That was dumb of me. What's the range of the parabola of graph A? So if I look at graph A, Brooke, it looks like it's everything below positive 6. How do I write that? First of all, range is wise. Below is less than. It is touching, so or equal to 6. What's the range of graph C? Graph C, only one height appears. The only height that appears is 4. There the range is a single value, y equals 4. What about graph D? Well, it goes all the way up, it goes all the way down. Its range is all reals. The constant term. This threw some people off. Listen, folks. The constant term also in a polynomial function, the constant term will also be the y-intercept. And the reason is, in any polynomial function, because you have x's and everything but the constant term, to find the y-intercept, you put a 0 in for the x, which means all the x terms will vanish. So the constant term for graph A is 5. The constant term for graph C is 4. The constant term for graph D is -2. 1 mark for each of those, so I guess this question is somehow out of 12. B says the equations are listed below. Match them with the correct graph. The x cubed, well, that was graph D. The constant term, that was graph C. And the parabola opening down, graph A. You know what? I think, I said this was out of 12. Actually, that's incorrect. This is going to be out of 6, a half mark for each one of those. That makes more sense to me. And that gives you a total score on this page out of 12. Okay? Turn the page. Number 3 says, describe the characteristics of each function below. Include the degree, the x-intercept, the y-intercept, the end behavior, the domain, the range, and the number of turning points. Wow. Okay. So, lots of information. I don't know if I gave myself enough room. Let me zoom in here a little bit. Include, now I can't see what I'm supposed to write. Hang on, let me. All right, let's see. Graph number 1. What's the degree? Got to be degree 3. It's a cubic. Let's do all of the degrees first. Graph number 2, the one below it. What's the degree? 2. What's the degree of graph number 3? It's linear, 1. What's the degree of graph number 4? Also 3. X-intercepts. Graph number 1, it looks like the x-intercept is 5, 0. If you just said 5, I'll take it, but it's technically a point. Looks like graph number 2 has 2 x-intercepts. It looks like, what do you think that left-hand one is? Maybe negative 1.5? Negative 1? I think negative 1 would be exactly halfway. It doesn't quite look, if you said negative 1, I'll take it, because I didn't give you good numbers on the graph. I was using graphs from other graphics. So I'm going to say negative 1.5, 0, and definitely the right-hand one, though, ln is 2, 0, yes? X-intercepts for the third one. Is that 6, 0? Maybe 7, 0. I'm going to go with 6, 0, I hope. If you said 7, 0, I'd take it. Sure, you weren't looking at your phone. X-intercept of the fourth one. There I'll go with negative 1, 0. And 3, 0. Y-intercept, that I can get. 0, 4. 0, negative 6. 0, 2. And 0, I don't think that's 8. I think it's a bit above 8. I'm going to say 0, 9. If you said 0, 8, I won't freak out because, again, this really wasn't enough a detailed graph for you to be able to get everything here. End behavior. End behavior is talking about where it starts and where it leaves in terms of quadrants. So if I look at the first graph, it goes from quadrant number 2 to quadrant number 4. The second graph goes from quadrant 2 to quadrant 1. The third graph goes from quadrant 2 to quadrant 4. And the fourth graph goes from quadrant 3 to quadrant 1. Domain. All reals for all of them. Domain's kind of boring. Range, a little more interesting. The first one, all reals. Shouldn't it be Y? Thank you. Sheesh. The second one, everything above and touching negative 6. Third one, all reals. Fourth one, I did it again. This is what happens when 5 students show up late. Fourth one, all reals. Number of turning points. The first one has 2 turning points. The second one has 1 turning point, which is also the vertex. Third one has no turning points. And the fourth one has 2 turning points. Then it says determine this, a half mark for each one of those. So there's 14 blanks. That means this question is out of 7. Then it says determine the sign of the leading coefficient and the value of the constant term. Sign of the leading coefficient. So the first one, what type of graph is the first one? Constant, linear, quadratic, or cubic? Okay, it's cubic. Cubic has a slope, sort of, the same way as lines have a slope. In other words, a linear graph, if it's going this way, is positive. If it's going this way, it's negative. A cubic graph, if it's going this way, is positive. If it's going this way, it's negative. So graph number 1 is going from the top left to the bottom right. That means the leading coefficient had to have been negative. Let's do all the signs of leading coefficient first. The parabola. Graph number 2. Which way does it open, up or down? So what does that mean? Positive. Graph number 3. Is that a positive slope or a negative slope? Is it going uphill or downhill? Downhill. Did I say downhill? Negative. Graph number 4. Positive. Working its way uphill. The constant term, which also happens to be the y-intercept. So the constant term must have been a positive 4. You don't have to put the positive there, but I did in graph number 1. Negative 6. Positive 2, and I don't know, what do you think? 9? I think above 8. I'd take it. Although, when in doubt, assume it's nice whole numbers, probably. Half mark for each of those. So can you give yourself a score on this page out of 18? Give yourself a score on the front page out of... Oh, there's one more page. Never mind. Not done yet. Ha-ha. Using the equation. Okay, now they didn't give me the graph. Okay, I can do this. Fill in the chart below. Possible number of x-intercepts. Graph A, what's the degree? 3. What's the possible number of x-intercepts? 3. Okay? Or 2, or 1, but not 0. But maximum you can have is 3. I'd have to graph it to see how many it actually had. Remember, we said for the x-cubed graphs, you could have 3, or you could have 2, or you could have 1. Possible number of x-intercepts for B, 2 or 1 or 0. Late person number 6. Y-intercept, 6. Y-intercept, -1. 0, comma 6 if you want to make it a point. 0, comma -1 if you want to make it a point. End behavior. This is a cubic graph, positive or negative leading coefficient. Positive, that means it's going that way. That means it's starting in quadrant 3 and ending in quadrant 1. Late person number 7. More focus, please. End behavior of graph number 2. Hey, this is a positive parabola. Means it looks like this. It starts in quadrant 2 and it leaves in quadrant 1. Domain, all reals. Domain, all reals. Range. Did it again. All reals. Range of this one. I need to graph it. So I'm going to go graph x squared plus 5x plus 1 plus 1 Oh, -1. Thank you, thank you. -1. I'm going to go Shift, View Window. I'll go View Window Standard. This is my usual start, and then oh, great. Oh, I want to do a G-solve minimum. -2.5, comma, -7.25. So what's the range? Everything above and touching -7.25. Possible number of turning points, 2 and 1. So a half mark for each of those out of 6. Give yourself a clear score out of 36, please. So lesson 6.4, modeling data with the curve of best fit. Brooke, by the way, what we're really looking at is in research. Say you go into medical research, you go into statistical research or whatever, you'll have several thousand pieces of data. And what you would like to try and do is see if you can determine the mathematical underpinnings, the mathematical law that can be used to hopefully predict things. And in particular, one of the things you're really interested in is what's called the correlation coefficient, R, and the R squared value. We'll look at that in a second. So I wrote here, the goal of this is to determine the quadratic or cubic function that best fits a set of data and to use that function to solve a problem. So we're going to try and find the curve of best fit. We do this in upper level physics all the time. You'll be in a lab, you'll be doing a lab, and you'll be gathering data, and they won't tell you the mathematical law. What you'll do is you'll look at the graph and you'll make a best guess. And you'll say, okay, maybe it's that. You run the data through some kind of curve fitting procedure. You say, it doesn't look right. Maybe it's one of these curves instead. You're literally kind of guessing and checking. And software has a tough time making the initial guess. Once you tell it what to guess, Silke, the software is great at generating the equation. But our eyes are still better at spotting the pattern. So this is, I believe, actual data. The table below lists the total estimated number of AIDS cases from 1999 to 2003 in the US. So we're going to type this in, except instead of typing 1999, we're going to type year one. I tried it with 1999, 2000, 2001, 2002, 2003, and what I found was that ended up being my y-intercept, and the graph was like way, way off the page in the thousands. So you ready? Get out your graph, clear any data that you have in your stat menu. So go to stat. Now, how do we delete data? Remember, that was F6, and then F4, delete all. Yes. Delete all. Yes. And then don't forget to press F6 again to get back to the calc menu. And so I'm going to type year 1, 2, 3, 4, 5. And then I'm going to carefully type in the other data, 41,356, 41,267, 40,833, 41,289, 43,171. Enter that, and it looks like we have 5 pieces and 5 pieces. Now what do we want to do? It's the same procedure as before. We're just going to change the very end. So we want to generate an equation. Now what do we do? No, we don't graph. There is no, nope. Oh, I'm sorry. You're right. I'm sorry, Colin. Graph. That was what we used last time, wasn't it? And then graph 1. Does that look linear to you? Now, it might be. It could just be with only 5 points. Maybe if I had 50 points, they would start to form a straight line. But right now, based on this data, I think it's a curve. What kind of a curve? It sort of, Brooke, looks a little bit parabola-ish. So I'm going to guess that first. I'm going to go calc. I'm not going to guess that it's an x linear equation. I'm going to graph that it's an x squared right here, quadratic. Okay? And hopefully it's giving you a parabola equation. It's saying y equals ax squared plus bx plus c, where a is what? Where a is equal to what? 345. B is equal to negative 1,705.65, and C is equal to 42,903. Now, I want you to notice this number here that says r squared. Jake, can you read to me what r squared is?
0.9.
Okay. The closer that is to 1, the better your graph matches the data. I'm going to back up one for a second, and I'm going to say, what if I had decided to think it was linear? What if I had tried to force a line on here? Look at my r and my r squared values. Are they close to 1? 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 No! Probably that's one other way you can say that's probably not my best guess. Now, I'm seeing a lot of people staring at their calculators. Is there anybody that couldn't get the graph 1 calc? Who can't get that right there? If you can't, now is the time to ask. Jordan. I wrote here rough sketch, so I'm going to very quickly go exit for a second and go back to this scatter plot. Here's my rough sketch. So, folks, you can roughly trace that into here. So you'll need to, I'm going to cheat a little bit, and I'm going to go yoink. Come on, computer. I'm going to copy it because I can. Make it a little smaller. So here's my rough sketch. You can just kind of trace your own. Okay? So I wrote here, plot the graph on a scatter plot. Does it look linear? What did we say? Does it look linear? No? What type of graph does it resemble? A quadratic, parabola, an x squared? Yep.
Wouldn't a cubic work better, though? Because it kind of has like this squiggle going.
I know that I yoinked this from data that was quadratic data, but you're raising a good point in the end. So Tiffany said, Mr. Dueck, wouldn't an x cubed graph work better? We don't have enough data points, and to enter enough data points to get a clear value, you would need like 300 or 400 data points. In fact, I had a lovely x cubed graph from the textbook that wanted you to enter 40 data points, and I just said, I'm not going to waste my time doing that. So in the questions, it'll say model this quadratically, or it'll say model this using an x cubed. Trust, and that's our fudge of we don't want to actually do a research project where we have 50,000 data pieces, which is what you would be doing in the field. Okay? I wrote determine an equation. So my equation was that there. Y equals 345.1 x squared minus 1705.7 x plus 42,903 points plus 42,903.6. That's the best fit equation. And Rosanna, pretty good. I got an r squared of 0.9. That's close to 1. It'd be nicer if it was between 0.9 and 1, like a 0.95. You know what? 5 data points. By the way, in case you're wondering, graph x cubed. Actually, it may be an x cubed, but I'm ignoring that. Did you try that and get a higher value? Yeah. Yeah. Okay. It says, use your equation to estimate the number of AIDS cases that might appear in year 8 in 2006. Okay. How do we do that? So we're going to go copy, and then hit enter to store your new equation. So copy, Hit enter to store your new equation. And now, if I look, I've copied that into both the graph and the table. And to get the estimated year 8, Rachel, I want to go to the table menu. So I'm going to go menu. For me, it's option 7. What option is table for you folks? Okay, as long as you know where it is. I'm going to set the table. What year do I want to find? Year 8. So how about start at year 7, end at year 9, go up by 1. Yes? Exit table. Oh, I forgot to turn deselect. There we go. Yep. Menu. Find table. Okay. It's menu 5, I think. Yes? And then set the table. No pun intended, but that's how I always remember it. Before I use a table, I got to set the table. We're trying to find year 8. So I said, how about go from year 7 to 9 up by 1s? Right? Do you get year 8, 51,347? Anybody not get that? Now is a chance to help me figure it out. Did you get that? Did you get that or not? Okay, if you didn't get that, you need to tell me because I need to come see. Hang on. So 51,347? Approximately 51,347. I doubt we could be that accurate, but we could probably say, in theory, if this trend holds, around 51,000-ish. In fact, probably somewhere 50,000 is about as accurate as we could be from only 5 data points. Turn the page. This one is definitely quadratic. A penny is dropped from the CN tower, and this table shows the penny's distance from the ground after various periods of time has passed. Those of you that are in Physics 12 with me or who are doing Physics 11, I used the distance quadratic equation to generate accurate data this time. So let's enter this data into our stat menu. How do I delete what I have? Delete all, and then I always hit F6 to get back to where I started from. Okay? Enter this data in, please. And when you're done, look up. I stole this from an American website, so it's in feet. I apologize. Yeah, we've turned the page now. Okay. Who needs more time to enter the data? No one said they need more time, but I see people typing like mad. Okay, thank you. Put the phone away, Rach. Face down. Everybody got it in? All right, let's graph. Graph 1. Hey, that looks an awful lot like an upside down parabola. It might be linear, but I think it's curved. So let's go calculate, and let's assume that it's an x squared graph. Ha! What's my r squared value here? That's bang on. Okay? If you were doing research in medicine, say you were doing a cancer drug or something like that, and you got that, honestly, you would be screaming with joy, and whatever drug company that you're working for is going to make a few $1 billion. Most of the time with cancer drugs or with medical treatments, you're lucky if you can get a 0.3, you're lucky. That means, well, it had some positive effect, but human bodies are so complicated, There's other stuff going on there too. It means, oh, maybe there's several thousand other factors besides just this medicine that are affecting this particular disease or cancer or whatever. So just letting you know, in industry, if you ever get a 1, that's like a high five, break out the champagne bottles, buy shares in the company, and go to town. Oh, and looks like rough sketch. I forgot to do rough sketch. What was the rough sketch, Mr. Dueck? It was like that. Rough sketch. Boom, 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 boom. Kind of like that. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Kind of like that. There's my rough sketch. And let's get the equation, Mr. Dueck. Y equals negative 16x squared plus 0x. I guess I don't need to write that. It's y equals negative 16x squared plus 1821. Y equals negative 16x squared plus 1821. By the way, I used x and y. What's sitting in the x column here? What am I actually measuring? Time? What would be a good variable to use for time? T. And what's sitting in the y-axis here? D. You know what? Here's the equation. D. Oh, it says use technology to find a polynomial regression. D equals negative 16x squared. X squared, Mr. Dueck? T squared, Mr. Dueck. Plus 1821. I really should have done that on the previous question, too. I should have changed the variables and maybe used y for year and n for number or something like that. Okay. Let's answer the questions. What's part A asking? How high is the tower? How do you know it's 1821? Because at time 0, how high are you? Also happens to be the y-intercept, the constant term, right? So the height of the tower is 1,821 feet. It says use technology to find a polynomial regression equation for the data. There it is. Caitlin, what's part C asking me to find? How the heck can I do that? Table actually won't get me there. First of all, I do want to copy the equation. So I've copied it. Table is good if they give me a time and they want a height. But you'll notice in part C, it's giving me a height. How high is the ground? 0. And it wants a time. Colin, what was that? So let's go to this time, y equals, let's go to our graph menu. By the way, I notice again my graph is deselected. I'll select it. Now if I just hit draw, oh, that's not a bad view window. It looks like it came up with a pretty good view window. Where is it hitting the ground? What do we call that? We've given it a fancy, what, Erica? Root. So I want to do a G-solve root. How many seconds before it hits the ground? 10.7. And make a little note. We did graph. Then we found the root. Then we found the root. Example 3. Some more medical data. The concentration in milligrams per liter of a medication in a patient's blood as time passes is given by the data in the following table. Okay, let's enter this data. So I'm going to go menu, stat, clear what I have. Christina, just follow along with this one. Don't, and you can get the other stuff later. Delete what you have. Looks like I have 6 data points. 0, 78.1. Type this in. Yes? Yes, typing this in. No, you need to practice typing this in. You really and truly do. Once you have the data typed in, if you want to do a graph, do a rough sketch, and try and find a polynomial regression, go ahead. But I'll pause here. Connor, what graph does that sort of vaguely look like? That's my first guess, okay? And again, in real life, Connor, you'd want to have like 50, 60, 100, 1,000 data points. We don't have time to enter all those, so we're kind of having to fudge our guesses. But I think, first of all, my rough sketch, 1, 2, 3, 4, 5, 1, 2, 3, oh, I got 0, 0, okay. My rough sketch, there's a point that does go through 0, 0. And then there, kind of like that. So let's guess that it is a parabola. So calc, let's assume it's an x squared. What's our r squared value, Connor? 0.9. That's pretty good. You know what? I think that's a good guess. So as an equation, we think maybe y equals negative 0.562 x squared plus 139.3 x plus, okay, so let's try this. As an equation, y equals negative 56.2 x squared plus 139.3 x plus 9.35. Is there anybody that can't get that to appear? Now is your chance to ask. I'll come help you. You got that okay, Jacob?
I actually didn't. I was just trying to figure this out.
Okay. Brooke, you got that okay?
Yeah.
Woohoo!
I got it.
Yep. Except, what is sitting on the x-axis? What did we graph on the x-axis from our chart? Time. What would be a good letter to use for time? So I'm going to rewrite this as t squared. And what are we measuring on the y-axis? Concentration. What would be a good abbreviation or letter to use for concentration? So I'm going to go C equals negative 56.2 t squared plus 139.3 t plus 9.35. So we've got an equation. Let's see if we can do something with this. I couldn't fit this all on the same page, so we're using this data, but turn the page. B. What's the concentration after 1.75 hours have passed? Okay, I want to copy, enter that equation. I have. Woohoo! Oh, by the way, I hit draw. There's the parabola. You can see it does a pretty good job of approximating the points. But you can also see there's some gaps. It's the best fit. Okay. How can I find the concentration after 1.75 hours? 1.75 hours, is that a time value or is that a C value? So they're giving me a time. What do they want me to find? A Y value? That's where the table method works really, really well. So I'm going to go table. I'm going to set the table. How about 1.74 hours to 1.76 hours and go up by 0.1. I have to select that graph. And I get a concentration of approximately, oh, did I set the table wrong? Oh, I want to go up by 0.01. Thank you. Whoops. And I get a concentration of 80.99. 80.99125. 80.99. 80.99. Hey, what are the units? What did I say were the units for the concentration in the chart? Sorry? Was it just milligrams? Per liter, right? How long until there's no more medication? How long? Now they're wanting me to find a time, an X value. Our best bet for that is to use the graph menu. Option 5, draw. Oh, I got to select the graph, Mr. Dueck. Option 5, draw. So there's the graph. When it says no more medication, what are they really asking me to find? Kyla, what? Sorry, Kyla. Gee, good gosh. Erica, what? Tired. The root. Okay. G solve, root. I don't want the negative one because there's no such thing as negative time. You know what? After about 2.54 hours, this medication should be totally through this person's system. Give or take. So if this was, for example, a medication that made people drowsy, you'd say, you know what, after 3 hours, it's safe to drive a vehicle or operate heavy machinery or something like that. You'd build in a safety margin, of course. This is our last one. This is a cubic regression in quadrillion BTUs. This one apparently is a cubic graph. So let's see. Enter this data. Menu. Stat. Oh, delete what's there. So it looks like my years are 1960, 1970, 1980, 1990, and then 1997 for some reason. Data 12.4, 21.8, 20.4, 19.3. Once you've entered the data, see if you get a graph that looks kind of like that. Is that right? Yeah. By the way, why would it look like this? What's the first year on the graph? 1960, no Middle Eastern tensions. Everything came from oil, not natural gas. Okay? 1970s, late 1970s in particular, Iran overthrew the Shah. The U.S. and North America lost major gasoline investments in the Middle East, and so they started switching to natural gas. They started going natural gas. In fact, you guys don't remember, but in the mid to late 70s, there was literally gas lineups. People were lining up for 5 and 6 hours at gas stations. Gas stations ran out of gas. Okay? Then we start drilling all over North America looking for natural gas. Oh, but Middle Eastern tensions go down. But have Middle Eastern tensions ever gone down completely? No. So recently we found huge natural gas deposits in North America, and the technology for getting them has gone up. So now we're using more natural gas, we're using less oil. So there is political reasons for that to be an x-cubed graph. I think this is actually reasonably accurate. Let's do a best fit. So calc. Hey, does that look like a linear graph? No. And by the way, if I tried fitting a linear graph, look at my r and r squared values. Pretty bad. Does it look like an x squared graph? If I try fitting an x squared, look at my r squared value. Pretty bad. But maybe it's an x cubed graph. Ooh. That's not bad at all. In fact, there's the equation, and you can see it models the data pretty good. Copy. All right. It says find an equation. So now this is going to have ax cubed plus bx, I just went down arrow, ax cubed plus bx squared plus cx plus d. So it's going to look like this. Oh, rough sketch. What was the rough sketch, Mr. Dueck? Dot, 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 dot. Dot, 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 dot. Kind of like that. Let's find a cubic regression. So it's going to look like this. Y equals ax cubed plus bx squared plus cx plus d. Except what do I want to use instead of letter y? What are we putting on the y-axis? Look at my chart. What's on the y-axis? Roy, consumption. What would be a good variable to use for consumption? C equals, and what am I putting on the x-axis? The year. I might use the letter y. The only thing is I worry if I put a y there, I'll think that's the graphing y. And so traditionally, we use the letter A for year because A stands for annual. So we don't get it confused. So I'm going to use an A. Now, that's a problem. You know what? I'm going to use T for time. It's a year. What do they want the A value to be? What did I say? X cubed. A is, okay, this is saying 1.478 times 10 to the negative 3. That's saying this, 0.001478 T cubed plus negative 8.78. So I guess not plus, but minus 8.78 T squared plus 17,397 T minus, negative, this is negative 1.148 times 10 to the 7th, negative 1.148 times 10 to the 7th. That's minus 1,148,1,2,3,4. That's minus that. 1,148 with 4 zeros. Those that are in chemistry or physics are used to doing scientific notation, but some of you have done it for a while. There's my equation. Okay. Says use the equation to estimate how much natural gas was consumed. They want me to find a consumption. They're giving me a year, 1982, so I'm going to go copy. I did copy it already. I'm going to go menu, table, set the table. To get 1992, I'll start at 1981. I'll go up to 1983. I'll go up by ones. Select that graph. In 1992, approximately, by the way, it's 20.2 quadrillion BTUs, because that's what I told you was the actual units on there. So 20.2 C equals 20.2 quadrillion. And I just got the quadrillion BTU by looking at the question, figuring out the units. How much natural gas will be consumed in 2015? Okay. Exit, set the table. 2014, 2016, go up by ones. In 2015, approximately 70.6 quadrillion. Homework. You need to practice this a little bit. Try from page 420 and 421, numbers 3 to 6 and number 8. I skipped the ones where you're entering 50,000 pieces of data.